Good morning, students. This is Raju, Associate Professor in the Department of ECE in Ramchandra College of Engineering. Today, I am going to explain about moment generating function in random variables and stochastic process. Moment generating function is used to find out the highest moment, higher moments if we are calculated for a random variables. So then it is named as moment generating function. If x is a random variable, if we are find out the moment or expectation, so then it is called as moment. If we are find out the first moment, that is x into probability of x gives the first moment value. That is called as averaging process. Here, if you are find out a highest moment for the given random variables, then it is named that is moment generating function. If capital X is a random variable with the probability density function fx of x, then the moment generating function is defined as mx of t is equal exponential or e of e power tx. Also, if it is continuous random variable, so then the moment generating function is defined as mx of t is equal minus infinity to plus infinity e power tx fx of x dx. So therefore, the moment generating function is also defined as if we are calculated the moment about the exponential signal, so then it is named as moment generating function. In the last class, we are already discussed about the moment. The moment means if we are calculated averaging value, so then on a random variables, then it is named as that is a moment. For a first moment, the averaging process E of x equal x into p of x gives the first moment. If you are calculated second moment, so then it is called as variance or dispersion about the mean. So means the first moment m1 equal, we can say that is sigma n equal minus infinity plus infinity xi into probability of xi. So that gives the first moment value. So here actually the moments are divided into, moments are classified into moment about the origin, moment about the mean. Moment about the origin means if you are calculated averaging process with respect to random variable x, with respect to random variable x, so then it is named as moment about the origin. If you are calculated that is nth moment, then it is also named as moment about the origin. That is defined as e of x power n is equal minus infinity to plus infinity x power n into fx of x dx. So this is the nth moment of the random variable x. If it is x into fx of x dx only, then it is the first moment or averaging value or mean value. If you are calculated that is x square into fx of x dx, that is called as that is second moment value. Second moment value. If you are calculated that is x minus m whole cube into fx of x dx, then it is named as that is qness or third moment value. So therefore, if x is a discrete random variable, then m of n equal I equal 1 to n xi power whole power n into p of x equal xi. As we discussed, the moment about the mean means if you are calculated averaging process on a random variable with respect to mean, so then it is named as moment about the origin or also called as central moments. So that is mu of n is equal expectation of x minus m whole power n into fx of x dx. So here we are calculating with respect to mean the variance or dispersion with respect to mean, that is x minus m whole square means that is the second moment, whole cube x minus m whole cube means that is the third moment. So x minus m whole power n means that is nth moment, are also named as that is movement about the mean. Then fx of x, here you can see the examples, that is if capital X is a random variable, then small fx of x equal 1 by 3. It is a density function of a random variable, density function. So then the x limits are from -1 to that is 2. Then find the movement generating function. As you discussed now, the movement generating function means if you are find out the movement for a higher moments, so then it is named as moment generating function. Already here discussed, that is mx of t is equal minus infinity to plus infinity e power tx fx of x dx. So here e power tx into fx of x dx. So already is given that fx of x value, that is density function of a random variable, is small fx of x dx. So that is equal, the limits are given that -1 to 2 e power tx into 1 by 3 fx of x given that 1 by 3, that is dx. Therefore 1 by 3 into e power tx, the e power tx integration is e power tx by t with respect to x. So means the limits are -1 to 2. Substitute the limits value, therefore 1 by 3 e power, in place of x we are substituting 2 value, e power 2t by t plus minus of minus means plus e power minus t by t. So this mx of t is equal e power 2t plus e power minus t by 3t. Like this you are finding the movement with respect to with respect to exponential. So that is higher movements if you are calculated. So then it is named as that is movement generating function. Is given that one more example. If capital X is a random variable having the moment generating function 2 by 2 minus t, then find the variance of x. Variance of x, variance means it is the second moment. The first moment means e of x equal x into probability of x. The second moment means e of x square, or that is variance of x equal to x minus m whole square into p of x dx. So that gives the variance of x. So solution is mx of t equal 2 by 2 minus t, that is equal 2 by 2, if you take common 2 outside, 1 minus t by 2, that is equal 2 to cancel, and remaining value is 1 by 1 minus t by 2. So that if you take it out, that is 1 minus t by 2 whole inverse. You can write it like this. So therefore that is equal, as you know that the formula 1 minus x by 2 inverse is equal 1 plus x by 2 plus x square by 2 plus x cube by 3 plus, like that it is having. So therefore you can write it as 1 plus t by 2 plus t square by 2 plus, like this. So here this is the first moment, this is the first moment. The coefficient of t by 1 factorial gives the, that is expected value or mean value, that is the first moment, that is 1 by 2. And the second coefficient is named as that is second moment. So that is e of x square is equal 1 by 2 again. So therefore, as you discussed in the last class, the variance of x is equal e of x square minus e of x whole square. E of x square value is that is 1 by 2, second moment e of x square, and e of x whole square equal to 1 by 2 whole square is equal 1 by 4. So like this we can calculate the, that is variance of x value. One more example is given that let f of xy is equal x into e power minus x of y plus 1 where the x greater than 0 comma y greater than 0 and is equal 0 elsewhere. Then find the moment generating function with respect to xy. As you discussed, that is moment generating function is defined as mx of t equal, that is e power tx into fx of x dx. If it is two random variables, so then we can go for, that is xy of t is equal minus infinity to 0 to infinity and 0 to infinity. The y limits are 0 to infinity, x limits are 0 to infinity, e power txy into e power minus, if it is single random variable, that is e power tx, but it is two random variables, that's the reason it is e power txy in multiplied with f of x dx value is given that e power minus x y of y plus 1 dx dy. Then take it outside, one limit, that is x limits, take it outside 0 to infinity of multiplied with these values e power minus x into 1, that is e power minus x, take it outside, and here already f of x into x value is there, that is in the problem is given that x, here you need to write x, this is the x into e power minus x outside, and next the remaining values are 0 to infinity, y limits e power tx, e power tx and e power txy and e power xy. So therefore if you take it outside common, xy minus 1 plus, that is e power minus xy means minus 1 plus and t e power minus ty. So that is t is there, e power txy, t is there. So therefore this is the e power txy minus e power txyt, e power xy and e power txy of dy of dx. So therefore 0 to infinity. So apply the limits for this with respect to y. So means 0 to, this is the common, that this is the constant value. So therefore e power minus constant value is downside, that is 1 by 1 minus t is the constant value into x, because we are integrating with respect to y. So that is the reason this total value is constant value, constant value. So that is the reason 1 by 1 minus tx is the constant value, and remaining only e power minus y is there of dy 0 to infinity. E power minus y integration is e power minus y of 0 to infinity. So that gives the e power minus y, if you are applied the limit 0 to infinity, e power infinity 0 minus of minus plus e power 0 means 1. So total it value is 1. So therefore x into integration of 0 to infinity, x into e power minus x into 1 by 1 minus t into x cancel. Again this 1 minus 1 minus 1 by 1 minus t, it is a constant value with respect to dx, means it is a constant value, and remaining value is e power minus x. So we need to calculate the integration e power minus x with respect to x. So means again e power minus x integration is e power minus x by minus. So therefore the 0 to infinity if you are applied, again it is e power minus infinity means 0, minus of minus plus e power 0 means 1. So 1 multiplied with the total value, that is 1 by 1 into 1 minus 1 by 1 minus t gives the same value. So therefore that is equal 1 by 1 minus t. So like this we can calculate the moment generating function. Actually moment means if you are calculated averaging value on a random variable, averaging value on a random variable, so then it is named as expectation or mean value. For example, if you want to find a averaging value, average value for the 2 plus 5, 2 and 5. So means you are calculating averaging value for a real numbers. 2 plus 5 by 2 gives the averaging value. So like that, if you are find out the averaging process or averaging value on a random variables, so then it is named as, that is expected value or mean value. So here movement means if you are calculated averaging process for a first movement or first averaging process, so then it is called as a movement. So if you are calculated higher movements, so then highest movements on a random variables, so then it is named as, that is moment generating function. Thank you.